Great, Saintsman, greetings. Good to see you guys for lesson 1.6, which is describing pairs of angles. So let's go ahead and get started here. I want to make sure that we address, oops, actually an example that came up in lesson 1.5. So right away, we can't make any assumptions about what we're looking at right now. We can't just automatically assume that this is a right angle just because it looks like the type. So in order to denote that this is a right angle, we actually have to have this little box right here to show that it has a degree measure of 90 degrees. Now, what we can do additionally is subdivide this angle. So if we do the following, I'm going to purposely draw this angle in such a way because I discussed this before. Saintsmen are really, really obsessed, it seems like, or addicted to even bisecting angles. There's nothing here telling us that this blue ray bisects this angle, because remember what a bisector is. A bisector, by definition, means that it's divided it into two equal parts. Now, it has divided into two parts, but we don't know if those parts are equal. What we do know about those two parts is they do have a specific sum. So we're going to name these angles 1 and 2. And since the two of them together through angle addition would have a degree measure of 90 degrees, these are by definition complementary angles. So 1 and 2 are complementary angles. Moreover, again, talking about what complementary angles are by definition, is that they have a sum of 90 degrees. So what we're saying is that 1 and 2 have a sum of 90 degrees. Okay. Now, these angles don't have to share side in order to be complementary, right? And we'll talk about the specific definition of when they share side. So let's just do another example here. We'll have this angle right here in space, and then another angle over here in space, and and we'll say that this guy is angle 3, and this guy on the right is angle 4, and angle 3 has a is equal to 60 degrees, while angle 4, I'm sorry, we'll call angle 3 30 degrees. My apologies. And angle 4 will be 60 degrees. It's a little bit more apt as to how they do it here because I don't want to be confusing. And when these angles, since 30 plus 60 is equal to 90, then we can say that angles 3 and 4 are also complementary. They do not need to share a side in order to be complementary. They just need to have a sum of 90 degrees. Okay, so moving on. Um, let's draw actually a specific instance here, and we'll talk about why this always will have the relationship that we're going to describe. And this, again, we're going to name our first two angles 1 and 2, which share a line here and are adjacent. Um, and these have a degree measure of 180 degrees. Um, when that is the case, angles 1 and 2, instead of being complementary, right? Complementary means that there's a sum of 90. When there's a sum of 180, these are supplementary angles. Again, that's just defining more things within the course, right? As we build our universe of geometry. The supplementary angles, as I said, have a sum of 180 degrees. And again, need not be adjacent. So let's draw a couple others here. Like, for example, I'll have angle right here and another angle right here. Sorry that my angles are a little wonky and aren't uh, super straight, but again, it's we can create it perfectly in the mind, if you will. Angle 3 here, we're going to say has a degree measure of 100 degrees, and angle 4 has an angle measure of 80 degrees. Now, gentlemen, what I had discussed is that specifically, um, and very simply, 100 plus 80 is 180. So by definition, angles 3 and 4 are supplementary. We'll discuss when they share side, like angles 1 and 2. Um, what makes those unique. So one and two share side in both examples, both the complementary and the supplementary angles, right? So when they share that side, they have a special name. So actually get rid of this little line here. Um, what we call these angles is we call them adjacent angles. Oh, sorry guys, it's probably difficult to read. Let me go ahead and enlarge that for you. They share a common side and a common vertex. In fact, I need to work on some of my default settings so you guys can, because I think this is going to change it's going to change the thickness of my pen if I do this. Okay. I have neither I'm going to draw this a little bit differently. I have neither a complementary set of angles or a supplementary set of angles, at least because I haven't defined them with having specific measurements that would fulfill those definitions, giving a 90-degree or 180-degree sum. So what I have here is two angles that share a vertex and share a common side. Okay. Um, this is where I'd like to get you guys to understand because we get adjacent, and adjacent means neighbor. And I want you to think about a next door neighbor. It's somebody who's going to share it, if you live in an apartment or if you live in a house. If you live in an apartment, your neighbor, your next door neighbor, you typically share a wall with them. And your next door neighbor with a house, you're going to share a fence, right? My classroom, I have a neighbor. I share a wall with Mr. Thompson's room. It's rather noisy in there. Many of the students are distracted and tapping on the walls. I'm skeptical of some of the learning that's going on in there from some of the sounds I hear. It sounds like they're having like a lot of fun. I'm not sure about the learning though. And then the other side, from the standpoint of house, right? I have some neighbors. They're lovely people. I had a neighbor who passed away a few years ago. He was a very nice man named Lloyd. We shared a fence. I can tell you some funny stories about him. He reminded me of the grubby old man from Up, where he would walk down the street with his walker that had the tennis balls on it. He'd walk down the middle of the street. It was pretty um, aggressive. And then we also like the fence we shared actually fell down at one point. And Lloyd was not aware of it for that it had even happened. I kind of had to educate him on the issue. After it happened, 3 days later, I went to talk to him about the cost of the repairs after I'd researched it. And then he had learned that our fence had fallen down. But wonderful man. God rest his soul. He's it was a World War II veteran, really, really nice guy. So back on topic here, BC would be like that shared wall or fence, for these two neighbors. So this guy, this Ray, BC, oops, is the shared side. And point B, this is the shared vertex. Okay. So by definition, angles ABC and CBD are adjacent angles. Right. So let's do an example here. So I'm going to give you guys, this is kind of a complex figure, so bear with me for a moment as we draw this guy up. I have an angle over here, which is angle ABC. And I have an angle over here, which is angle oops, HJK. And then I have one more. Oh man, this is pretty crooked, huh? Or maybe it's intentionally so. It's an angle. It's got another ray coming out of it, um, where I have D, E, F, and G. And here we go. There's some measurements we're going to fill in interior to each of these angles. So for ABC, this is 28 degrees. HJK, this is 72 degrees. For DEG, this is 108 degrees. And for GEF, we have 62 degrees. Remembering how we named these angles, utilizing the vertex as that middle point, the second point kind of matched in between. Our directions for this problem is that we are going to name a pair of complementary angles, a pair of supplementary angles, and a pair of adjacent angles. All right. Oh, man. Let's go ahead and correct that spelling. Now, gentlemen, I'm usually not impressed. I'm not impressed by many things. I'm not really impressed by calculating power. Like that you guys, do these things in your head. It's not important to me that you can do that. Let's utilize all that brain power that you have on logic and reasoning and problem solving rather than on calculation. Calculators can do that for us. So it's not even, I guess, encouraging. But you just need to utilize a calculator. It's going to take away a lot of the calculation errors that I'm kind of seeing from time to time. Many of you have bought into that in the class, but still, I'm seeing some of you guys, it doesn't impress me. A problem came up on lesson 1.5 where we did 37 plus 21. Of course, I know you guys know how to do that. I really hope that you do. So, as we do this, we're looking for complementary angles, guys. And I need two. So people are going to look at this and be like, oh, yeah, 28 and 72, that's 90. Nope. Calculate better, please. That's, a 100-degree sum. So it doesn't have to be adjacent, but my complementary angles, and in this case, they aren't, are the two that are going to have a sum of 90, which in this case is 28 plus 62, or angles ABC, because I have to name the angle, right? B being the vertex, and angle GEF. Oops, that's really lousy. There you go. GEF, where E is my vertex, G to E to F. Okay, 62 plus 28, that will give us 90. Let's name a pair of supplementary angles. Oops. Okay, supplementary. So again, I think you guys look at this and visually see, right? There's this kind of like break in it, but that doesn't necessarily mean, let's do a double check here. 108 plus 62, they're adjacent. But 108 plus 62 is 170. So it doesn't give us the supplementary angle that we're looking for, right? But 108 plus 72, that, right? So this guy and this guy will give us the supplementary relationship. So we're going to name those. We have angle DEG and angle HJK. All right. And then last but not least, we have our adjacent angles. Which two are neighbors? Which ones share a side? Well, ABC and HJK, they don't share a side with anything. Where we have is the side EG, right? That DEF has interior. So DEG and GEF share EG. So therefore, those are my adjacent angles. They are neighbors sharing a side. Okay. Continuing on. Let's do another example. Here's a problem. We have angle 5 is a complement of angle 3. And the measure of angle 3 is 53. So we're going to find the measure of angle 5. Now, I had some questions in class regarding that M angle 3, meaning the measurement. It's a notation issue. There's several ways that we can actually measure uh, angles in terms of the units we use. Now, you guys are used to when we do length, how, for example, if you measure the length of your pencil, you could use centimeters, you could use inches. Um, but we haven't really discussed that with angles. Angles actually can be measured a few ways. One of the ways we commonly, we're going to do it for the most part in this course in degrees. There's another popular way to do it, which is utilizing radians. Okay, so just something to consider. We have angle 3 plus angle 5 is equal to what? We're being told 3 is a complement of 5. In other words, 3 and 5 are complementary, meaning that their sum is 90. And then now we can substitute. I have effectively what's similar to being an angle addition statement, but it's just this is the definition of a complementary angles. Okay, that's why I can write that down. This is what we need to start with, guys. I understand you guys can do all this arithmetic, but again, please, angle 3, we're going to substitute and have this as 53. This is plus angle 5, and that's going to be equal to, we already were given 90 as the angle measurement, okay? And then we're going to utilize, again, there's no angle subtraction here, so we just set this guy up this way, right? Or the definition of complementary angles says that the sum of two of them equal 90, so we have to set it up that way. There's no subtraction statement that we would make there. So we do 90 minus 53, and according to our calculator, is 37, okay? So the angle 5 is equal to 37 degrees. Okay, next. We have angles 1 and 2. Angle 1 and 2, angles 1 and 2 are supplementary angles. And we're going to find the measures of the angles when the measure of angle 1 is equal to 7x plus 13 degrees. And the measure of angle 2 is equal to 25x plus 7 degrees. And remember, we need this little, we need to put this little angle symbol in there. Okay. I need this definition of supplementary angles, which is to stating that angle 1 plus angle 2 is equal to 180. And that's because that's how we define supplementary angles. Okay. So I need you guys to create that initial postulate or definition of why you can set up your problem the way that you can. Okay. We need reasoning that backs our problem solving, not just a random set of thoughts. I understand you can do these calculations. You guys crushed these algebra problems. You flew through these during class. But now we're going to apply some problem solving logic here. So this is the definition of supplementary angles. That's why we can set up the problem this way. All right. Which we learned back here is that supplementary angles have a sum of 180 degrees. One thing I want to do real quick is I want to pause this. I want to go back and make a point here that we neglected earlier, which is, let's actually go all the way back to the beginning with angles 1 and 2. These angles are complementary. We also have these supplementary angles, okay, that were 1 and 2. When we have supplementary and complementary angles, only 2 angles may be complementary or 2 angles may be supplementary. This is what I mean. Let's say I had the following. I just put another line in here, okay? And now I have 3 angles. I'm like, oh yeah, those 3 angles are complementary to each other. Absolutely not. That's nonsense. Now what I could do is add whatever this angle is and this angle, right? To create the angle that is 2 through angle addition, and then through angle addition have 1 and 2, right? So I have my 2 angles, then that would have a sum of 90. Therefore, fulfilling the definition of complementary angles. So I want to make sure I make that point. Only two angles are supplementary or complementary to each other. This is one of those ways, not to play gotcha, but I'm able to see if you guys are actually listening to this video. That and actually on the next thing, if you guys bother to ask after we discuss vertical angles, there's a story I can tell you guys during class. It's a fun one. Angle 1 is 7x plus 13. Only just depends if you guys are watching and then, bother to ask me. 7x plus 13, it's angle 1. Angle 2 is 25x plus 7. And that's going to be equal to 180. Okay? Except for I'm going to go back to my blue here because I just want to show you guys where I was substituting here. Okay? But I substituted angle 1, right, was this. And angle 2 was this. And then I'm now off to the races doing algebra. So now I do 7x plus 25x, which is 32x. I do 13 plus 7, which is 20, is equal to 180. I subtract 20 from both sides. 20 cancels, so I have 32x is equal to 180 minus 20, which is 160. I'm going to divide both sides by 32. The 32's factor out, so x is now by itself. It doesn't cancel with factors. It factors to a 1, so it's just 1x. And then 160 divided by 32 is equal to 5. Congratulations, we did that. Cool. So we have this, but that's not what it's asking for. It wants the measures of the angles. It wants angle 1. It wants angle 2. So let's evaluate. Angle 1 is equal to 7 times 5 plus 13, or 35 plus 13. 35 plus 13 is equal to 48. Okay, now, two ways to go about this, guys. Now I have angle 2, and it has to have a sum. 1 and 2 have to have a sum of 180. So I could do the following. I'm gonna evaluate real quick and show you guys. You can go 25 times 5 plus 7, right? 25 times 5 is 125 plus 7, which would give me 132, which of course it would, right? That really makes sense. Now, remember, 1 plus 2 was equal to 180. So could we have done the following? Could I have said, okay, I had solved for angle 1. And since angle 1 is equal to 48, can I use that to solve for angle 2? Well, absolutely. Logically speaking, we can, because they have to be since they are supplementary. So angle 2, oops, is equal to 180 minus 48, which is 132. Okay, so it doesn't matter which way you do it. I don't care. Just make sure you get it. Next, we have to discuss linear pairs and vertical angles. So, linear pair. Again, we showed you guys angles 1 and 2 earlier, and angles 1 and 2 are a linear pair. What it means is that a linear pair is a pair of angles formed off of a line. This is what's great about linear pairs. The name and the definition, the definition is within the name. Pair of angles, two angles formed off a line, linear pair. These angles are both supplementary and adjacent. All right, so what that means, they have to fulfill both, so angle 1 and 2 are adjacent, and because they're formed off of a line, they are supplementary since they are a linear pair. Are 1 and 2 supplementary? Yes. Why are they supplementary? Because they are a linear pair. Okay? Not all supplementary angles are linear pairs, but all linear pairs are supplementary. Remember that. Next, vertical angles. Are formed angles, there we go. Are formed when sides of two pairs are formed when sides are, sorry, are two pairs of opposite rays. They are, by definition, non-adjacent and congruent. Non-adjacent, not neighbors. Guess who? 3 and 5. These guys, these are vertical angles. Now, people are like, oh, is it because they're stacked? Nope. It's because they meet this definition. 3 and 5 are vertical. And so are 6 and 4. These are non-adjacent, formed the same way. It's just an issue of orientation, right? Oops, oh my gosh, it turned out really crazy looking. Angle 6. All right. Ask me in class about vertical angles as it pertains to neighbors. I have a colorful story about my old neighbors, Bruce and Donnie, who were not adjacent next door neighbors. They had a relationship where their house was vertical to mine. One, two, three, 4, 5. Here we go, guys. Let's figure out what's vertical and what's linear pair, okay? Do I have any vertical angles here? And some of you guys are like, oh yeah, this guy and this guy, 3 and 4. Nope. Not at all. They can't be. First of all, I mean, it's not that they just don't look congruent, but they're not formed in the same way, right? Oh my goodness, I didn't mean to do that. Remember, I started with 2 lines that intersected at this point. So the only 2 vertical angles that I have before I subdivided and created angles 2 and 3 were angles 1 and 5. These are the only 2 that are going to wind up being vertical, okay? Do I have any linear pairs? And the answer is yes. Got a couple of them. I've got angles 1 and 4. Moreover, I've got angles 4 and 5. Those are both linear pairs, which have a sum of 180 degrees. Okay, last example. 2 angles form a linear pair. The measure of one angle is 8 times the measure of the other angle. Find the measure of each angle. Angle 1 and angle 2 are a linear pair. Right? Therefore, because we have just 2 angles, so let's call them 1 and 2. So that means angle 1 plus 2, angle 1 plus angle 2 is 180. So the first angle, it says one angle is 8 times the other. So in other words, we're going to say we have x plus 8x, right? Is going to be 180. So x plus 8x, because, you know, the first one, it's like we're saying the 8 times, right? 8 times this guy will be this guy, right? And now we're speaking using the same variable. Oops, go back to black. 9x is equal to 180. Divided by 9 on both sides to get the 9s to factor out. So x is equal to 20. But that's not what it's asking for. It's finding the measure of each angle. But we know here x is this, which is really angle 1. So angle 1 is equal to 20 degrees. And then angle 2 is equal to 8 times that, which is 160. And that makes sense because 20 plus 160 is equal to 180, therefore fulfilling the definition of being supplementary. And of course, they have to be supplementary because they're a linear pair. There we go, Scienceman. Good luck. See you in class.